We have two more talks, and the first one is about argument strength via probabilistic interpretations, and it's work done by Niki Pfeifer and Christian Fermüller, and the talk is given by Niki.
Thank you very much. So the outline is as follows. After a brief introduction, I will present some qualitative principles for attack and support relations. Then I show how we justify these relations in terms of coherence-based probability logic. And then we consider some weighted principles and their interpretation. And finally, I will report some results of an experimental study of the proposed semantics. So our approach to argument strength is as follows. We look at argument strength from an indirect and semi-abstract perspective. It is indirect because we interpret argument strength via logical rationality principles on support and attack relations. It is semi-abstract because we focus on the logical form of claims, connecting different arguments either by attack or support. Thus, the focus of our approach is just on logical form. This means the semi-abstract. It is neither on fully instantiated arguments nor on fully abstract points of view like Dung's argumentation frameworks, which are basically identified as graphs. So the strategy is as follows. We first formulate qualitative attack and support principles. Then we give a probabilistic interpretation. Specifically, we use coherence, the coherence approach to probability as a selection criterion for these principles. And then we consider a natural extension in the sense of looking at weighted principles, so weighted forms of attacks and supports and their probabilistic interpretations, and then some experimental evaluation. So logical postulates for attack principles. We denote attack by this double-headed arrow. So A attacks B, an argument with claim A attacks an argument with claim B. This is what this arrow means. And this denotes simply the classical logical entailment. So A classically entails B, namely directly and self-evidently. So we first consider a general logical attack postulate, which was presented by Corsi and Fermüller in 2017. And this means that if G follows logically from F and if X attacks G, then it seems natural to say that X attacks F. And this implies some weak attack principles. For example, if X attacks A or X attacks B, then it should also be the case that X attacks the conjunction of A and B. And so we can form various kinds of qualitative attack principles. We can also take into account concerns about relevance with this principle. So if it is not the case that X attacks A and X attacks B, then X attacks the material conditional if A and B. And here's something for negation. If X attacks A, then it is not the case that X attacks not A. So these are these principles. And we can also formulate principles for support and even mixed principles. So by support, we formulate with this arrow, with this double arrow, which means that an argument with a claim A supports an argument with a claim B. And we also have this general principle, if G follows logically from F, and if X supports F, then X also should support G. And here you can see a couple of principles. I will not go into the details. It's just to communicate the intuition that these principles involve conjunction, material conditional, disjunction, and negation. And we also can formulate some logical principle for mixed principles where we combine attacks and support relations. For example, the following: if X supports A and X attacks B, then we would also like to have that X attacks the material conditional if A then B. So now let's go to the justification. And by justification, we use the coherence approach to probability, which goes back to De Finetti and more recent works, and extensions and generalizations is given here. And as you know, the coherence approach is a subjective approach to probability. It interprets probabilities by degrees of belief. It does not require a complete algebra, And while many approaches define the conditional probability by this fraction of the joints over the marginal probabilities, where they need to assume that the conditioning event or the probability of the antecedent must be positive, you will face problems with such definition in case the antecedent has a 0 probability. In the coherence approach, however, the conditional probability is primitive and is able to manage 0 probabilities in antecedent properly. And this has some relevance in some borderline cases where you actually get differences in the calculations in the probability propagations, in contrast to when you cannot deal with the 0 probabilities. So this is important. The coherence approach has rich applications, for example, to imprecise probabilities with a lower and upper bound, non-monotonicity. It also allows for modeling connexivity and also logical operations on conditionals. And there are many bridges to other uncertainty measures like to possibility theory, the Schäfer belief function, fuzzy sets, and also to Wolfgang Spohn's ranking functions. By probability logic, in a nutshell, I just want to say that it's the study of uncertain argument forms, that the consequence relation remains deductive, and it is all about to propagate the uncertainties from the premises to the conclusions. So now we will apply this kind of probability logic, which is based on coherence, to our semantics for attacks principles first. So the suggested reading of F attacks A is that the conditional probability of not A given F is bigger than some threshold. And we define this threshold simply as something bigger than 0.5, strictly bigger than 0.5. So the first principle here, X attacks A or X attacks B. Therefore, if X attacks A and B, is justified since this relation holds in probability logic. The conditional probability not A given X, this is positive, or if the conditional probability of not B given X is positive, then it must be the case that the conditional probability of not A and B, the negated conjunction given X, is also positive. And in this way, we justify also the other attack relations. So we have done this in a paper in 2018, we presented to the WUPES, and also coherence is also used as a rationality framework for sorting out problematic principles. So for example, this principle from if X attacks A and B, then X attacks A or X attacks B, we can see that this should not hold because in probability, the corresponding relation does not hold. For example, if you just interpret B by not A. So this is does not follow, and therefore you can use coherence to sort out these problematic principles. Now for support, this is a new work. Support relations are interpreted in our framework simply as the corresponding conditional probability is bigger than this threshold. And by using this idea, we can simply, as we did for the attack principles, also justify the support principles. So for example, if X supports A and B and X attacks A, then X attacks B. And this holds simply because the corresponding constraints in probability logic hold. For this principle, which also, by the way, corresponds, the probabilistic version corresponds to the end rule of system P, the probabilistic version of the end rule. This holds in our context. So this validates our corresponding support principle only if the threshold is equal to 1. Otherwise, this would be smaller. But if T is 1, then we also get 1 here, and this justifies our principle. And in a similar way, we justify other support principles, as you can see here. For example, X supports A or X supports B. Therefore, X supports A or B, which is justified by the corresponding probabilistic inference rule. We do this in a similar way for the mixed principles. For example, this mixed principle that I presented previously is simply justified since this relation holds again if T, the threshold, is equal to 1. Now, a small remark, recall that X attacks A is interpreted by the corresponding conditional probability that not A given X is bigger than the threshold. And we also interpret X supports not A with the same conditional probability. So hence they attack and support relations in our semantics are interpreted as dual. Attack excludes support and vice versa. But the two claims may be unrelated. So if X does not attack A and X does not support A, this can hold. Now let's have a look for a generalization concerning weighted principles. So far we considered qualitative principles. So now we consider varying strength of supports, which we denote with a weight here, X over the support relation in with the reading that F supports A with the weight here, where we choose a value within the unit interval. And hence we interpret this as the corresponding conditional probability. So for example, with this, we can also justify if X supports A to the degree small x, and X supports B to the degree small y, then X supports the conjunction to the degree Z, where Z is given by the Fréchet bounds. And this is the corresponding inference rules that holds in probability logic, and this justifies this argument form. And specifically, it justifies the following, which is just to say that the conclusion is smaller than the minimum of X and Y, which corresponds to the Gödel T norm, and it also justifies the product T norm, which is just the product of X times Y, under this assumption that A and B are stochastically independent given X. And it also can justify the Lukasiewicz T norm, which means that the conjunction is bigger than the maximum of X and these values here. And of course, it also allows to show that these two rules are not validated, and they just differ from the above ones, that we turn around the inequality symbol, and these rules here, they do not hold in probability logic, therefore they do not justify the corresponding support principle. Now, a further generalization concerning mixed principles, namely quantitatively weighted mixed principles. Again, consider this semantics here, that F supports A to the degree X with the conditional probability of A given F is bigger than this threshold. Analogously, F attacks A to the degree X with this corresponding conditional probability here. And this allows to justify this example here of a mixed principle. This is again the same principle, but now weighted, right? We have the value, the weight X here, the other weight Y here for the attack, and therefore the weight for the attack here is given by the set, and this is justified by the corresponding probability propagation rule. Now I come to an experimental evaluation. We did an experiment so far only on the attack principles. We are currently planning to extend also the experimental work towards investigating support principles. And for the first one, we tested 139 students of TU Vienna. They were in their second semester and they have not received any specific training in logic yet. And it were only German native speakers. We had 19 tasks which were translated into abstract tasks. We had 3 booklets, one booklet with an open response format, which I will show you in a minute, and 2 booklets with closed response format, where we selected the even and the odd numbers of tasks, because the closed ones, they took more time to solve. Therefore, we split the closed ones into two conditions. And we generated a random task order, and each booklet consisted of 2 sides of a DIN A4 page. These were the tasks we investigated. So these were the argument forms, these rules here, which were generated from our semantics for the attack principles. And we translated them into some abstract tasks, which I'll show you in a minute. And here you see the various kinds of booklets. The B and the A and the C refers to the booklets which were given here. And we also added some tasks which were designed simply to investigate some consistency checks, for example, that A does not attack, whether A attacks A obtains the value 0, of course, or if you don't know nothing about A and B, you cannot say anything about whether A attacks B. So these were these consistency tasks just to see whether the participants really understand what's going on. So the closed response format was formulated, for example, as follows. So this is a sample task A1. If A attacks with exactly strength 7 the claim B and C, then you have here various candidates, and the participants had to choose whether they are wrong or correct. And here is a visualization of the corresponding point values or intervals. And the corresponding open response format was formulated in the following way. Here you see that the participants had to fill in here either at least, exactly, or at most, and here they should give a value. So this is open because they had to generate something from the numbers given here in the antecedent of these principles. And they also had to mark it here just to be sure that they match what they write also in their cognitive representation. So this is basically how the experimental material looked like, and the main results are as follows. The agreement between the predictions and responses is rather modest compared to other direct tests of coherence-based probability logic. So I did many experiments on coherence-based probability logic, for example, on all the rules of system P, on the conditional syllogisms, and many more tasks, and we found quite a high agreement between the predictions and the actual human responses, but here it was really modest. The responses in the open response format were closer to the predictions compared to those to the closed response format. So where they had actually to generate the numbers and so on, the participants gave better results. More than half of the participants responded by at least a coherent lower or a coherent upper bound in the open response tasks. A possible reason is that the open response tasks require a deeper cognitive processing compared to the closed response tasks. Another explanation, which I did not write down here, is that the attack principles, they always involve negations, at least the implicit negation, right? Because if A attacks B, this means that the conditional probability of not be given A is high. And already this processing of negations is very hard for people. So this is probably also a very important reason why it's confusing for the participants to do these tasks. And we expect for the new experiments, which is on support relations, to get better results. Almost all participants, however, responded as expected in the control task. So it was not completely complete nonsense that they responded, but it seems that they really had troubles with these tasks. So future experimental work is devoted to adapt the experimental material to investigate support relations, and we will see whether we get better results. So now I'm coming to the concluding remarks. That is, we follow an indirect approach to argument strength via logical principles for qualitative and weighted support and attack relations, and also mixed forms of them. Coherence can serve to guide the rational selection of appropriate principles. So you recall, if the corresponding probability constraints are satisfied, then our principle holds. Although our interpretation of attack principles is intuitively plausible, the experimental results are relatively heterogeneous. Future work is needed to investigate support experimentally. And here you see that the papers on which our work is based. So thank you very much for your attention. I think Chris is also here, and we are both very happy to answer your questions, and looking forward to hearing your comments.
Okay, Niki, thank you very much.